Hi, welcome to my video on extra practice. The extra practice here is showing the relationship between the value of the discriminant and the X-intercepts of a graph. What I've set up is three equations. One is A, y equals x squared minus 2x minus 3. B is y equals x squared plus 2x plus 1. C is y equals x squared minus 4x plus 5. I'm going to find the vertex of each one of these, then the y-intercepts, excuse me, and then the x-intercepts, and do the graphs. And on the next page, I'll show you how this discriminant fits in. The vertex is x equals negative b over 2a. A is 1, B is negative 2, C is negative 3. So it's the negative of a negative 2 all over 2 times A, which is 1. So that gives 2 over 2, which is 1. So the x coordinate is 1. Now I'm going to sub in 1 in the place of x. Sub in 1 in the place of x. 1 squared is 1. Negative 2, negative 3. That gives me negative 1 plus, subtract 3 is negative 4. So the vertex is 1, negative 4. B, again, A is 1, B is 2, C is 1, and x equals negative b over 2a, which is the negative of b is 2, a is 1, so that gives me negative 2 over 2, which is negative 1. Now I'm going to sub negative 1 into the equation for x, and I get a 1 minus 2 plus 1, I get a 0. So the x-coordinate of the vertex is negative 1, the y-coordinate is 0. And the same for C. I have, excuse me, x equals negative b over 2a. Again, a is 1, b is negative 4, c is 5. So that's the negative of a negative 4 all over 2 times a, which is 1. That gives me 4 over 2, which is 2. And I'm going to sub 2 into the equation. And that works out to be a 4 minus 8 plus 5. Negative 4 plus 5 is 1, so the vertex is 2, 1. Find a y-intercept for each. The y-intercept is when we let x equals 0. So there's the equation. Put 0 in the place of x. And I get a 0 minus 3. So the y-intercept is negative 3, or you could write 0, negative 3. And again, we're going to put 0 in the place of x in this equation. So 0 goes in the place of x. And you can see that you get 1. So it's 0, 1. And we're going to get the y-intercept of this equation. So we're going to sub 0 in the place of x again. 0 minus 0 plus 5, 5, or it's the ordered pair 0, 5. If you notice, when the equation is written in this form, which is a standard form, by letting x equal 0, you're getting the y-intercept to be negative 3. The y-intercept is 1 when you let x equal 0. When you let x equal 0 here, you get the y-intercept to be 5. So even though I'm working all these out, it's just as quick to say the y-intercept is negative 3, 1, and 5 because you're letting x equal 0. Just a fast way. How do you get the x-intercepts? By letting y equal 0. So let's let the equation x squared minus 2x minus 3 equals 0. And that's factorable, quadratic. X squared is x and x. Factors of 3 are 3 and 1 because that's the product of negative 3. The sum is negative 2. So I have and negative 3 plus 1. X minus 3 is equal to 0. X plus 1 is equal to 0. X is 3, or X is negative 1. And that's the X-intercept. And again, the X-intercept is 3 when Y is 0. The X-intercept is negative 1 when Y is 0. Because the X-intercepts cut the X-axis, and that's the Y coordinate of 0. And in this equation, I'm going to let Y equal 0, so I get X squared plus 2X plus 1 equals 0. Quadratic is factorable. Let's see. X squared is X and X. The factors of 1 are 1 and 1. The product is plus 1. The sum is 2, so it's got to be positive 1, positive 1. So X plus 1 equals 0. X plus 1 equals 0. X is negative 1, or X is negative 1 again. Negative 1, 0, and negative 1, 0. Notice we have there's an X-intercept of negative 1. Cuts the X-axis at negative 1, but there's only one X-intercept in this one. And in C, I'm going to let X squared minus 4X plus 5 equals 0. Now, what are the factors of 5? Let's see what happens there. We got X and X. Factors of 5 are 5 and 1. Product is plus 5. Sum is negative 4. But since the product is positive, I must have 2 pluses, which gives me plus 6, or 2 negatives, which gives me negative 6. So this is not factorable. So I have to use the quadratic formula, A, B, and C. So X equals negative B plus or minus the square root B squared minus 4AC all over 2A. That's the negative of a negative 4 plus or minus square root of B is negative 4 minus 4. A is 1. And C is 5. All over 2 times A, which is 1. That's a 4 plus or minus. And notice we got 16. If you work that out, that's 16. Subtract 20, that's a negative 4 all over 2. And that's 4 plus or minus. Square root of 4 is 2. Square root of negative number is an I over 2. Divide by 2. 4 divided by 2 is 2. Plus or minus 2I divided by 2 is I. So we get imaginary numbers. When we have imaginary numbers, that means there's no X-intercepts for this parabola. So let's graph using the vertex, the Y-intercept, and the X-intercepts. So the vertex is 1, 4 for the first one. X is 1, negative 4. X is 1, negative 4, 1, 2, 3, 4, right there. The Y-intercept is negative 3, so it cuts the Y-axis at negative 3. And the X-intercepts are 3 and negative 1. X is 3, and negative 1 are the X-intercepts. And we'll draw that parabola. So you can see the parabola comes down like this, loops, there's the vertex, and goes back up. And if you notice that 1 unit to the left, you got negative 3. So if I go 1 unit to the right, I'll have a negative 3 also. There's a symmetrical. And let's do number, or B. The vertex is negative 1, 0. X is negative 1, Y is 0. The Y-intercept is 0, 1. X is 0, Y is 1. And the X-intercepts are negative 1, 0. So the parabola, this is the vertex, so it leaves here and goes up through like this. So 1 unit to the left is 1, so 1 unit to the right, we should have a 1 because it's symmetrical. And notice your vertex is it only cuts the X-axis once, and the vertex is your X-intercept. We say is bouncing off, and it is bouncing off at 1, and it has 2 roots, but the roots are equal. we'll see that coming up. And here we have a vertex of 2, 1. X is 2, Y is 1. We have a Y-intercept of 5. 1, 2, 3, 4, 5. And we have no X-intercepts. So this is the vertex, and it's going up through the 5. There it is there. And if that's 2 units that way, 2 units to the left, so if I go 2 units to the right at 4, I should have a 5. Because it's symmetrical. Remember, your axis of symmetry is straight down through the 1 like that. The axis of symmetry is x equals 1. The axis of symmetry here is x equals. Now look what I got done. All that work, and I put it in the wrong. Good thing I checked. No, Matt, just a minute, a mishap here. I put it in the wrong spot. The vertex is -1, 0. X is -1, Y is 0. Sorry about that. Good thing you got to keep checking, especially with me, because I make some errors. So the vertex is -1, 0. Why is it 1? I don't know. But one of those common mistakes that I make. I know what I'm doing, but we just make mistakes. So sorry for that. So the vertex is -1, 0. And the axis of symmetry is x equals -1, straight down through. X equals -1. And right here, the axis of symmetry is x equals 2. It goes down to the x coordinate of the vertex, the vertical line. Okay, let's turn over. Now, number 5, state the roots of each from number 3. So if you look at number 3, the roots is when you make the equation equal to 0. So if you let the equation equal to 0, you will get x squared minus 2x minus 3 equals 0. So the roots are the x-intercepts. So the roots are 3 and a -1 when you work this out, which is what we did. So the roots are the x-intercepts. In B, the x-intercepts, the roots are -1 and -1, -1, -1. And in C, the roots are 2 plus I and 2 minus I when you let y equals 0 in your equation. Now, based on what we have as the roots of the x-intercepts of the graph, classify the roots as real or imaginary, non-real, equal and non-equal. So these two roots are real roots, and notice they're not equal. These two roots are real roots, but they're equal. And these two roots are imaginary. And imaginary roots have to be unequal. 2 plus I, 2 minus I is not the same. And they're imaginary because of the i's. Notice imaginary begins with I. Imaginary. Number 7, state the number of x-intercepts in number 3. In number 3, the number of x-intercepts, the number of roots is 2. In B, the number of x-intercepts is 1 because they're equal. And in the number of x-intercepts in this one, notice the graph had the number of x-intercepts. There's none because we got imaginary numbers. It didn't cut. If you go back and check the equation. Oops. There's the equation. Notice the roots are imaginary. There's right here is -1, -1. These are real, unequal. These are real, equal. These are imaginaries. And notice the graph. There's no x-intercept. There's the vertex going upward. There's only one x-intercept here. And right here there's 2 x-intercepts. But this one has none because you have imaginary numbers. let y equals 0 in each equation, find the value of the discriminant. So if we let y equals 0 in the equation, so we get x squared minus 2x minus 3 equals 0. And your discriminant is b squared minus 4ac. And again, a is 1, b is negative 2, c is negative 3. So b squared is negative 2 squared. A is 1, and c is negative 3. I get a 4 plus a square, multiply, and then add. I get a 20. Oh, 12. See? 4 times 3 is 12, and add, it gives me 16. Got to be careful. The discriminant is 16. And we have the equation as x squared plus 2x plus 1 equals 0. And we work out the discriminant. D equals b squared minus 4ac. A is 1, b is 2, c is 1. So d equals 2 squared minus 4 times 1 times 1. A is 1, c is 1. That's a 4 minus 4. The discriminant is 0. And in C, the equation is x squared minus 4x plus 5 equals 0. D equals b squared minus 4ac. Again, a is 1, b is negative 4, c is 5. B is negative 4, A is 1, C is 5. 16 minus 20, negative 4. And what we just derived, and I'll just show you here, what I just derived, if I want to look at this closely, when I did the quadratic formula here, the discriminant is underneath the root. Notice the discriminant is b squared minus 4ac is underneath the root. This b squared minus 4ac became a negative 4, which is what I have here. B squared minus 4ac, there it is right there, which is a negative 4. And when that's a negative number, we have imaginary roots. So let's go back to the sheet. Here we are, and answer the question. So we got a 16 for discriminant, 0, and a negative 4. From number 8 above, this one, classify the discriminant as d equals 0, d is greater than 0, d is less than 0. So in 16, d is greater than 0. This d is 16, 16 is greater than 0. B, the d is equal to 0. C, the d is negative 4. D is less than 0. So, what am I getting at? Well, here we go. Let's draw a quick picture of the graph. I'm going to draw this graph on number 1 again, just redraw it. There's the vertex, there's the X-Intercepts, so on. There's the Y-Intercept. So, this is a graph over again that I did before on the other page, but I just wanted to draw it to show you. And this X-intercept here, I have these two. X-intercept is negative 1. Remember, I made a mistake and put it at 1, so put this right here. There's the vertex. The vertex is 2, 1. The Y-intercept is 5. So the parabola does this. So, notice your discriminant. Notice you have two X-intercepts. Discriminant is greater than 0. When the discriminant is greater than 0, you have your d is going to be a positive number, so you're going to get 2 X-intercepts. When d is equal to 0, you only have 1 X-intercept. D is equal to 0. You only have 1 X-intercept. When d is negative, you have no X-intercepts. Notice there's no X-intercept. The parabola is not cutting the x-axis. So when your discriminant is greater than 0, you have 2 X-intercepts on your graph. Discriminant is equal to 0, you only have 1 X-intercept. The X-intercept is the vertex that lies on the X-axis. And when your discriminant is negative, you have no X-intercepts. You have imaginary roots, which means you have imaginary roots is no X-intercepts because they're not real. So that's just a practice reviewing solving by different methods and using discriminant. How the discriminant tells you if you have 2 X-intercepts, 1 X-intercept, or no X-intercepts. And if you like my video, click the like button, the subscribe button, notification bell, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.